Finally, it's spring. The sun is shining and the flowers are blooming. You know what that means? It's HALCON release time. Hello and welcome from MVTech headquarters here in Munich. I'm today's host, Yihui Chu. I hope you're all doing fine and excited to hear about new features of HALCON 2305. Today's speakers are Gärtner, our Product Marketing Manager of PM, and also Peter König, Application Engineer. So as usual, there will be a live Q&A section in the end of the webinar. If you have any questions, just simply type in the GoToWebinar and we're going to answer them later. That's it for now, so let's jump right into the HALCON 2305 and see you later in the live Q&A section.
And also from my side, a warm welcome to the presentation today. Today, we are speaking about HALCON, our latest release, HALCON 2305. With HALCON, with this release, we have many new features like the deep counting, a deep learning-based counting method, the training mode for the Deep OCR detection model, the training mode for the 3D gripping point detection, and as well a nice usability feature, the easy extension interface. What it is, you will learn later on. And of course, there's no HALCON release without further speed-ups and improvements. But before we dive into all the details, let me inform you that we also released a new deep learning tool version, Deep Learning Tool 2304, and it now includes the object detection training and evaluation, as well as the instance segmentation training and evaluation. So for both methods, you can now do the whole workflow within the deep learning tool. And how does it look like? Now at the top of the tool, you can see training, evaluation, and export. So you have the whole tool workflow for the object detection, as well as you can see here for the instance segmentation. And we also updated another tool, the MVTech Software Manager. If you are already using HALCON or Merlic or the deep learning tool, you probably know the MVTech Software Manager. Here we released our newest version 1.3 and we listened to your feedback. We have various UX improvements, so now you can see which packages will be updated. We have an improved session reuse, a sys-tray icon now, so you can see when the software manager is running, and we added a feedback button. So, if you have feedback regarding the software manager or other products, please press the feedback button. And now, let's start with our first feature, the deep counting. To count things is a really standard task in the field of machine vision. And we have offered many different algorithms to solve the task. Like one algorithm you would usually pick is the shape-based matching. So we can see we have some metal pipes here in this image. We would train a shape-based matching model with a template. Then we are doing some parameter tuning, and then we get a decent result. But it has some problems. If you have perspective deformation, if you have reflections, the shape-based matching may struggle with the images. And therefore, we want to introduce a new method, the deep counting, a deep learning-based approach to count things within an image. Here, you have also to draw some template regions, but you have to do less parameter tuning, and it's still really robust for reflections, local reflections, or perspective deformations. And how it works will Peter show to you now.
Thank you, Jan. So this is the schematic of how it works. So we want to find in this image the grapes on the bush here. So what we're going to do is we draw some templates of the grapes. So for example, one grape here in the middle and one on the side, so that we have most of the variations of the grapes covered. And then we learn the network and get an accurate count of the grapes. So not just a count, but also an approximate location of the grapes. And what I can do now is I can use different template regions. So first of all, what you see here are axis-aligned rectangles. We strongly encourage you to use axis-aligned rectangles if it's possible, because it's the fastest way to use deep counting. So something like this. But you can also use other region types. So for example, circles or rectangles with orientations. You can even use arbitrary region types, but we strongly discourage you to use region types or rectangles that have strong aspect ratios, because this will make deep counting very slow in the processing. For axis-aligned rectangles, we additionally also recommend to use sometimes augmentation, because it makes the method more robust. And of course, for axis-aligned rectangles, this would be an augmentation in a 90-degree step size. And even for circular regions, if you decide to use them in your application, augmentation of rotation can be useful, since the objects are seldomly rotationally invariant. And how is the workflow looking like for deep counting? In the offline step, you just create your deep counting model with, depending on your setup, with some generic parameters. Then you need draw deep counting templates that lets you interactively draw templates onto your image region. And then you need to set deep counting model parameters. Here you can set the typical deep learning model parameters that you might be familiar with, such as the device, and also some more special parameters, such as the max overlap or something like this. And as the final offline step, you need to prepare your deep counting model with the templates. And once you've done that, you can apply your prepared model. So you use apply deep counting model and on your newly image that you want to infer on, and you get your deep counting results. And additionally, you have then a def display procedure to see your counting results, and you get a nice image like this with the count and, in addition, the location of the objects. And you get a confidence value of your location. And deep counting, as Jan already said, can robustly count different objects. So in such applications such as product counting in such a tray, such glasses that have a lot of reflections and a difficult background, it is very powerful to find all the objects that you want to count. And the most important part here is, of course, that it's contactless counting. So you don't need to have a mechanical sensor or anything. Just from the image, you count the objects. This gives applications in product counting, in traffic flow monitoring, and stuff like this. Inventory management, as you can see from this example from the beginning, when you want to count these metal rods that are in the workspace, and something like this, these green rods that are already in the product basket.
Thank you, Peter. So we have seen that deep counting can solve many difficult applications, and this is really just a few images for the training. It's robust for different object types, especially for local reflections and deformed objects. The application development is really fast, so you don't need a lot of knowledge about parameter tuning, and also you don't need a lot of labels to train the deep learning network. And now the big question, deep counting, it sounds like a deep learning method. Will it be part of the deep learning module? No, it will be not. For us, deep counting is more related to the matching methods, and so it will be part of the matching module. But we not only developed new methods, we also updated or improved our existing methods. And so we want to release now the detection training for Deep OCR with the latest HALCON release. Detection training, what is it? So HALCON out of the box comes with a pre-trained Deep OCR model. It already performs quite well. As here we have styrofoam, we have some text on top, and we can see the pre-trained model can find the text, the bounding box is okayish. But when we have a look at the character scores at the bottom, we can see that the character scores are a little bit blurred. So with a tighter bounding box around the text, we could get better results here. And therefore, we can now train the detection model. So we can label the bounding boxes on multiple images, retrain our Deep OCR model, and get better bounding boxes for our texts. And that also continues to better character scores and to better results. That's our second new feature.
So let's have a look at the workflow again. How does this work? Well, it is a deep learning method, so it follows the usual 4 steps. You need to prepare your data, train your network, evaluate your network, and then it's ready for integration. And preparation, as you might be familiar with from other deep learning methods, works really well, data preparation within the deep learning tool. And for this, we also updated our example program, Deep OCR pre-label dataset. What does this do? Well, as Jan said, we have this pre-trained Deep OCR network that actually works quite well already. So we can use this to pre-label our dataset and thus save time. So for example, in this image, we already find with our pre-trained network these word boxes and pre-label them. They might be a little bit wrong, but it's a good starting point for your own labeling. And then you can export this dataset and just load it into the deep learning tool with the Deep OCR project type. And you already have the pre-labeled bounding boxes that you just need to improve upon. You could also, of course, just start from scratch, Deep OCR project type, and label your bounding boxes. And then we have in the new deep learning tool, we have an export button, easily localizable, and then you just export your deep learning data set and can use it then within HALCON for the training. Now an important part is the pre-processing of this data set. Because there are 2 things that we want to mention. First of all, that the pre-processed DL dataset does an aspect ratio preserving fit. So a deep learning model always has a defined image size. And if you put in images that have maybe a different aspect ratio than the image size, the images would normally be skewed towards the new image size. But for Deep OCR, this is very important that you have an aspect preserving fit so that the text on the image doesn't get distorted. So what you do here is aspect ratio preserving with a 0 padding, that the image stays the same way. And the second thing that preprocessed DL dataset needs to do is it needs to generate the targets from the labels. Because unlike object detection, where the target or the label, basically the bounding boxes of the text, are the actual target for the network, in Deep OCR, the network predicts score maps. So these score maps that are pictured here, character score map, so where is a character, link score map, what characters are actually linked as in a word, and orientation score maps, how is the bounding box oriented. And the preprocessed DL dataset procedure does that for you from the labels in the bounding box labels of your text. So it generates automatically these score maps that the network then needs as targets for training. Now, the rest of the workflow is actually done in HALCON. So you need to start off, of course, with read DL model. Then you get your model handle as per usual. And you just need to train DL model. And this looks like any other deep learning method that we have. You get your progress window and you get your current result window, where you can inspect how the network is doing and what parameters you're actually set for this epoch. Once your model is trained, you need to evaluate it, of course. And evaluate DL model standardly evaluates against our pre-trained network. So how did Deep OCR pre-trained perform against your now fine-tuned model? And usually you have an image like this, so that with your fine-tuning, you actually improved upon your evaluation data. After this, the workflow is a little bit different than with other deep learning methods, but you might be familiar with it from the recognition training of Deep OCR, you now need to create a Deep OCR instance which contains both models, the detection model and the recognition model. And within this instance, you now need to set the Deep OCR, the detection model, the Deep OCR param detection model to your retrained model handle that you just evaluated to be good enough to use in your application. And once this is set, you can just use apply Deep OCR on your specific images for which you retrained, and you get a better result than what you got from your pre-trained model. Yeah.
Okay. Thank you. Let's sum up what we have seen right now. So with the Deep OCR detection training, we can improve the performance on our specific target domain. What does it mean? So from now on, we can improve our results for arbitrary printing types and character types. And we also can improve the readability in noisy and low contrast environments. So you get better confidences. And really good, the whole labeling can be done with the deep learning tool, which is really convenient. Our third new feature is kind of similar. So next to the Deep OCR detection training, we also integrated now the 3D gripping point detection training. For those who don't know the 3D gripping point detection so far, it's a method, deep learning method, that suggests gripping points for a vacuum gripper in 3D scenes. And that's for random unknown objects. So you don't have to train for specific objects, it just finds appropriate gripping points. So here on the left-hand side, we can see the grayscale image of the 3D sensor. In the center, in red, we can see the suggested gripping areas with the center gripping point. And on the right-hand side, we can see the 3D gripping pose in the 3D scene. This network works really well with many different sensors. But we heard from some customers that there are problems with low-resolution sensors. And so now we want to provide a training method to improve the results also on low-resolution sensors. And therefore, we have another slide here. We can see the kind of poor performance with the low-resolution sensor. We can see the pixel edges, blurry edges, and we can see the gripping area is not really good. Now with the pre-training, we can improve the results really very much. So we can see with the fine-tuned model, we get good gripping points, and therefore the labeling is really convenient. It's really similar to the semantic segmentation labeling. Okay, and go on, Peter.
Yeah, let's talk about the workflow again. You might be familiar with this slide. Again, it's a deep learning method, so the workflow stays the same. And again, the preparation can be done in our deep learning tool. As Jan said, you just load your image, you label your gripping points with a semantic segmentation map, basically. You only need to label the gripping points on the objects, the rest is background. And then you just export your data set and get your XYZ mapping, intensity, or RGB image, depending on what you have, and of course, your label images. And the training, again, done in HALCON. And again, as you remember from before, it looks the same. So you get your progress window and you get your current results in the within HDevelop. And if you want to check this out, of course, we have a standard example that you can start your development with depending on your application. The evaluation then again compares against the pre-trained gripping point detection. So it usually looks even stronger than with Deep OCR detection, because if you have a poor low resolution sensor, the results were not really good, but you can pre-train it now and you can fine-tune it now, I'm sorry, and compare it against the pre-trained model, and you get a much better result. The integration then, of course, also done in HALCON, and these packages, for example, are then robustly detected after fine-tuning. So not just the low resolution is a problem here, but also, of course, the touching surfaces of the packages, which the network sometimes identifies as one surface and gets a a common gripping point on them, which might be in between the packages, which is not really usable. And when you when you fine-tune your model onto these images, you see that you get much better gripping points, and you can also see on the right side much better gripping poses. This standard example shows the workflow of your training. So just use our standard example to start with your application. Just load in your images and you can start training on your application. And not just low resolution sensors, also, for example, different types of sensors. So what you can see here is acquired with the time of flight camera. Before, the pre-trained model wouldn't find any suitable gripping points on this small image and the can it tries to grip in this image. But once you fine-tuned your model onto this specific sensor data, the gripping point is found robustly.
So with the new 3D gripping point detection training, you can really improve your pick-and-place solutions. So you get better results on your specific hardware setup, or if you have a really challenging environment with a lot of ambient light or so on, you can also get better results in this environment. And the labeling effort is really low, so you only have to coarsely label the gripping areas, which is really fast. And the whole labeling, again, can be done in our deep learning tool. That's really convenient. But so now we talked a lot about our deep learning functionalities, our new deep learning features. But we also have another nice usability improvement, the easy extension interface. Some of you maybe already know the extension package interface, which is kind of similar, but now we have a better improved version. The easy extension interface, a .NET adapter for the extension packages to write your own extensions in HALCON with .NET. So you might experience the following situation. We need a custom extension for HALCON. And then
I'm the HALCON programmer, and I say, well, writing extension packages is really time consuming and requires in-depth knowledge about HALCON and in-depth experience.
But now MVTech is releasing an easy extension for .NET.
And then, well, .NET is great. This will save so much time. We can do that right away.
So the nice thing now, you can write your own operator in .NET, and you can control external hardware devices or embed external libraries into HALCON. And how it works will Peter show you now.
So let's have a look in detail. First of all, you can use, if you have a look at the code on the left side, you can use HALCON.NET data types and HALCON operators within your easy extension. So for example here, htuple is used in this function. Next, you can also use typical .NET APIs directly in the easy extension. So math.square root is used here in our easy tuple square root parameter. You can simply define your own operators with this .NET attribute HALCON operator. So this is essential that you need to use. And most importantly, no definition of operator def file is needed at all. And you simply use the required adapter that is implemented in our standard example and start your easy extension now. So this should make the process of writing extension package much easier. And this new operator that you then defined and compiled with this sort of script is automatically integrated into HDevelop. And you can find this under operators, user extensions, and then here the easy tuple square root. So already in your HDevelop to just ready to use.
Yeah. So the easy extensions offer you a simple method to integrate your own user code into HDevelop. So you can write your extensions with .NET, and with your own operator you can control external hardware devices, you can embed an external library, and so on. And really nice too, you can also use those operators in your runtime environment. But you have to use the HDEV engine to embed the operators. So pay attention to, these operators are not supported via the language export or the language interface. If you want to use them, please use the hdef engine. That's our fourth major feature. And we are at the end of the high-level features, major features presentations. Now we have a lot of further improvements that Peter wants to show you. And we continue with core and I/O.
Thank you, Jan. So a lot of further improvements. Let's have a look through all of them. First of all, just for core HALCON operators, you can now create a constant image border with the new operator addImageBorder. So simple operator, but quite powerful in the right setting. It has a couple of settings, so you can either use just one image border for all sides. So if you use just 50 here in this case, all sides will be enlarged by 50. You can use also a tuple of two values, then the up, down, and left, right are expanded differently. And you can use 4 different sides, so you get left, right, up, down, different enlargement of the image. This can be, of course, useful for bar and data code, for example, if you have a disturbed quiet zone and you need to enlarge the image in such a way. Now, another feature that we have is that the memory block now supports a generic socket interface. So within HALCON 22.11, the memory block was able to be written and read from buffer, file, and image. But now it's also possible to send and receive data from the generic socket to have a communication channel in this way in HALCON 23.05. Now onto a new acquisition interface that we have. Usually when you used something like a webcam or something like this, you needed the direct show interface. And the direct show interface was not very convenient, because when you selected the direct show interface and clicked on connect, you usually needed administrator privileges to run. And not everybody has administrator privileges, especially on company PCs, something like this. And the new Media Foundation interface that we now implemented just works plug and play without any such privileges needed. So you just select Media Foundation when you connect for example, your webcam or something else, and just click connect, and it just works. Now, what is new in the world of HDevelop? First of all, a nice usability feature that you can now search the procedure combo box. So if you have a project where you have a lot of procedures implemented, you can just search through the procedures here in the combo box up and just find your procedure instantly in the search box. It sorts by local, referenced, and others, so that you can see the different types of implemented procedures. In addition to that, users are now notified if the reference files have been changed. So within your HDevelop instance, when it's running, and from outside someone changes some parameters, for example, in Notepad or something that you load in HDevelop, you get a notification within HDevelop that it detected file changes and if you want to reload it or not. This setting is, of course, a little bit takes a little bit runtime, since, well, it does a check, and if you want to, if you're not interested in this check, you can also, of course, disable this within the settings. Now let's look at the world of bar and data code. We improved our .code reader. It can now read .code under more challenging conditions. So these .codes, for example, were very difficult to read because it had local distortion or reflections, something like when there's a foil over it or something like this, or were very blurry. And all these .codes can now be found. With our challenging in-house .code dataset, we increased our performance by 10%, so by a large margin for reading .codes. So this should make your .code reader much more robust. You can now have a lot more control in your found barcodes with the parameter max code length. So if for some reason you have a lot of codes on your image you only want to find codes that have a specified length, you can now use max code length. For example, if you would just use the barcode reader, you would find, of course, all of the codes on the image. But then if you would set barcode parameter to 4, the barcodes that have a longer code length than 4, so 1, 2, 3, 4, 5, 6, for example, would not be found anymore. And you can filter your results like this. In addition, for dot codes, we now, not dot codes, sorry, for data codes, we now support continuous grading according to the printed standard. So in HALCON 2211, we had, for the print quality inspection, we just had numerical values for the grades, but there's in the standard it is defined that you also can have continuous grades, and these are now implemented according to the standard, so that you can find, for example, for this barcode, for this data code, you get continuous grades, as you can see on the right. Another thing for PQI, you can now set a fixed smallest module size for the 2D codes. So this is for the reason that the size of the synthetic aperture in the standard is derived from the smallest module size in the application. So module size, if you're not familiar, you can see on the left side what the module size of a data code is. And you can just set this with set data code 2D param with this parameter. And you set it in pixel, and now you can ensure that it's standard conform to use the output in your calibrated setup, basically. Because the smallest module size defines your synthetic aperture. HALCON now supports a new type of barcode. So UPC-E barcodes were already supported, but now we support also the UPC-E1, so the barcode with number system 1, basically. This is an addition. It is not defined in the standard, but it's widely used in some industries, and now we support it as well. So you can not only read the UPC-E barcode, but also these additions with number system 1. And the different these types of barcodes have different add-ons to ensure different informations. Another thing in the world of barcodes is that you can now check the contents of GS1 codes for conformance with GS1 specification. So is your GS1 barcode actually up to the standard? And what this is called is linting the code. And that's why the parameter is called GS1 lint passed. So this is just a true or false parameter. In this case, when you look at the GS1 code below, it would say false. Since not everybody is an expert on GS1 conformity, we also have the GS1 lint result. So it actually gives you an information what is wrong with the current barcode, why it's not in conformance to the standard. So in this case would be the numeric check digit is incorrect. So the check digit is the last digit in the marked area. So the 7 would be incorrect in this case. Then in addition, in the last digit, a 0 or 1 would be required to be conform to the standard. And it requires AIs. What AI in this case means is application identifier for AI 15. So the 15th application identifier misses some numbers here. So this is not everybody needs to understand this, but it just gives you information in accordance to the standard if your code is up to the standard. Now let's have a look at matching and 3D. We have a new method called stochastic for hand-eye calibration. So this provides estimates and corrections for the uncertainties in robot poses. So usually when you do hand-eye calibration, you take the robot pose, so the pose from the base of the robot to the gripper of the robot as a given. You get this from the robot operating system and you take this as gospel. This is a given, that's fine. But now we can also provide uncertainties for these robot poses and thus corrections. So this will lead to more robust results with respect to the noise of the robot pose, because these robot poses are not given, they are not perfect, they can have some inaccuracies in them. And this leads to a simultaneous refinement of hand-eye poses and camera parameters. And this, as with a lot of calibration types, works of course best with many calibration images. So if you can use a lot of calibration images, this method will work quite well. For what is it suitable? It's suitable for moving camera, so the camera is mounted on top of the gripper, or a stationary camera is also works also. You can use any kind of robots, articulated robots or SCARA robots with this new stochastic method, and you can just use camera and calibration plate as well. It's not working for the calibration of 3D sensors. How does the method then work? What do I need to set? You just need to set the calibration method within set calib data. So the optimization method here is set to stochastic. And then you just use calibrate hand-eye, and the stochastic method is used to calibrate your hand-eye setup. And now if you want to inspect your results, you use get calib data, of course. And for example, you can use the tool in base pose corrected. So what is actually my corrected pose for the tool, depending on the tool that I have. Then you can check out the hand-eye calibration error of the corrected tool and the camera calibration error of the corrected tool. And you can also check out the translation deviation that you have from your tool pose and the rotation deviation that you also have from your tool pose. And how does this look like in practice? How do the results look like? If you look at these images of the calibration plates, the zoomed in images of the calibration plates, if you just use nonlinear in contrast to stochastic, there's not a lot of difference. So the stochastic method works as well as nonlinear, but the stochastic method also provides the corrected tool poses. And if you use them again you correct your tool poses and then check out the results of your calibration, you see on the right side that the calibration was better. The marks are found more robustly. We of course have for this also a standard example available that will show the workflow of the stochastic method, but it's not that much different. It's simple that you set the stochastic methods and then afterwards correct for the tool poses. Now let's move on to the world of shape-based matching. There we have a nice new parameter. If you have a specific setup and you want to check the model overlap globally. What does this mean? For example, you have this type of setup, okay? You have these, I know it's a very generic setup, but you want to find the circles and the squares in this. And you have two shape models, the square and the circle, of course. And now the task is to find only shapes, so circles and rectangles, which do not overlap by more than 50%. So between the shape models, they shouldn't overlap. In HALCON 2011 progress, this was not possibly globally. So if you now try to find this and didn't and just set a max overlap, it just checked the max overlap within your model. So the two circles don't overlap more than 50%, so both are found, and the two rectangles don't overlap more than 50%, so they are found. But you want to check in between the models, so globally. And for example, here, the one circle is fully within the rectangle, so we don't want this model to be found. And now you can set the parameter global max overlap enable. So this is just a true false flag. You want to enable this checking for global max overlap. And now in 2305, when you set this parameter, the circle within the rectangle is not found anymore because it checks globally for the overlap. Now, to sum up, we go back to the world of deep learning where we actually started. We also have a bunch of smaller features in this world. First of all, we have a new pre-trained model for deep OCR detection. So you can, of course, retrain your model now, the detection model, but also our pre-trained detection model has been improved. So it has improved accuracy. Here you can see on our data set, we improved our accuracy by about 4%. And you have improved domain generalization, so you get better results on difficult domains. And most importantly, we have an improved shift equivariance. What is this? What are we looking at here? When you move the setup of your crop of your images, as you can see here below in green, the crop of the images is moved, so the text on the image actually moves further to the left. The Deep OCR detection performance was not constant. You would think that the text is found on one image, so it should be found depending on if the text moves a little bit, it shouldn't matter. But this was not constant. This is a difficult thing to get right with deep learning networks. But now we improved upon this property, and as you can see on the right, if you move the crop on the image, the text is found robustly in every crop. In addition to this improved accuracy, we also have a new compact detection model, so a lightweight detection model that you can also use, that might be interesting for you if you, for example, use a Deep OCR on an embedded board, because it has faster inference and a reduced memory footprint on just a marginal penalty to the accuracy. So the model is just smaller and is thus faster and has a lower memory footprint. And you can just set this with set Deep OCR param. You just select not default, but compact, and you select a different model like this. Now let's move on to the world of AI squared optimization, so hardware acceleration for deep learning. We heard from a lot of customers that that they have an issue when they need to change some parameters in the production line. So for example, imagine this scenario. We need to adjust the recognition alphabet of the model in this setup. So we want to find, for example, the label, the text on the labels of the bottles, and the text changes because the bottle changed, for example. Then the engineer said, well, the optimization is very time consuming. I need to move the model again to a machine where I can do the optimization and then put it back into the machine. And this just takes too much time for our production line. And now we offer, so MVTech now allows to set the parameters after the optimization, at least the parameters that are not necessary for the optimization. So if you just want to, for example, change the recognition alphabet, this now works. So if you have your model, you used AI squared, so TensorRT or OpenVINO or stuff like this. You have your optimized model now, and now you can use setDL model param or Deep OCR param, depending on or deep counting param, depending on what you're doing. You can still set this after your model has been optimized. So for example, in this small code snippet, you create your Deep OCR model and push it onto TensorRT, so you optimize model for inference, yeah? And the recognition model in this case. And after this optimization has been done, the set Deep OCR parameter for the recognition alphabet that you might want to change, this works. So you can just set the parameter after the optimization. For a complete list of which parameters you can set, you can check out our documentation because it's too much to mention here. Now, last but not least, Jan already said, we give you, of course, some speedups for different operators. Most notably, zoom image size or zoom image factor, excuse me, is now faster for byte and uint2 data types, up to 95%, so a lot faster. And generate Gauss pyramid is now faster for also byte and uint2 data types by up to 70%, depending on your instruction set, AVX2 or SS3-2. So that's it for our new feature presentation. We now have a survey for you, so this will be posted in the chat. So please fill out our our participant survey. In the meantime, we'll gather up your questions and then we will do some Q&A afterwards. Thank you for your attention.